Okay, objectives for this lesson, we're going to graph quadratic functions using standard form. Okay, so this is 8-3, quadratic functions in standard form. So standard form is the equation ax squared plus bx plus c. Okay, and we're going to look at what c does. Okay, so what information does c provide about standard form? Well, you can use Desmos and go ahead and see this, but I'll just tell you right now. The value of c corresponds to the y-intercept. Okay, so c is the y-intercept. Okay, why is it the y-intercept? Well, remember, whenever I cross the y-axis, x is always 0. So let's plug in and see what happens if x is 0. So f of 0 is equal to a times 0 squared plus b times 0 plus c. Well, 0 squared is just 0, and 0 times anything is just 0, so that term's gone. B times 0, that's gone. So it's just c. Okay, so that is why c is the y-intercept. Okay, so standard form of quadratic function is f of x equals ax squared plus bx plus c, where a cannot be 0. Okay, the value c is called our y-intercept. Okay, when we did vertex form, we talked about the axis of symmetry and the vertex. Well, the axis of symmetry, this time we're going to use a formula. Axis of symmetry is the equation x equals negative b over 2a. Okay, and a and b come directly from standard form. Okay, and then the vertex, we're going to actually use our axis of symmetry to help us find it. Okay, so this is the x-coordinate of the vertex, that negative b over 2a. And I'll show you how to find the y value here in a few minutes. Okay, so you got to know this formula, x equals negative b over 2a. So let's graph a quadratic function. Okay, so we have the function 2x squared plus 4x plus 3. We need to find the axis of symmetry, the vertex, and the y-intercept. Those are the easy things to find that are going to make it very easy to graph. Okay, so remember, y equals ax squared plus bx plus c is standard form. Okay, so in this problem, what is our a value? Well, a is in front of the x squared, so a is equal to 2. What's our b value? B is in front of the plain old x, so b equals 4. And finally, what is our c value? C is the constant on our end, so c is 3. Okay, so the first thing we need to do is find the axis of symmetry. Remember, the axis of symmetry is x equals negative b over 2a. So b is 4, so negative b would be a negative 4 over 2 times what's a? Well, a is 2. Okay, so if I actually go ahead and calculate this, I get negative 4 over 4, which equals negative 1. So my axis of symmetry is the equation x equals negative 1. Okay, and let's go ahead and plot that. So remember, I like to do that with a dotted line. Okay, so there's my axis of symmetry. Okay, so the next thing we do is find the vertex. Well, this is half of the vertex. It's at the point negative 1 something. Well, how do I find that y value? Well, to find the y value, all I need to do is plug in negative 1 for x. Okay, so anywhere I see an x, I'm going to plug in negative 1. So 2 times negative 1 squared plus 4 times negative 1 plus 3. Okay, well, negative 1 squared, remember, is just a positive 1. So I get 2 times positive 1 is a positive 2. Plus 4 times a negative 1 is a negative 4, plus a positive 3. 2 minus 4 is negative 2, plus 3 is a positive 1. So my vertex is negative 1, 1. So negative 1, 1. Okay. So again, to find the y value, you take your axis of symmetry and plug it in for x. Okay, the next thing we do is find our y-intercept and plot the reflection. Okay, remember our y-intercept is just c. So the y-intercept is 3. So I'm going to plot that. Okay, and remember, this is symmetrical. So I am 1 spot away from my axis of symmetry, so I go 1 spot on the other side. And there's 3 points in my parabola. Okay, this says then plot 1 more point and reflect it. Okay, so what value do you want to use? Well, we already used 0, so let's just plug in 1. Let's plug in 1 and see what happens. Okay, let's see what we get. Okay, so anywhere I see an x, I'm plugging in 1. So I have 2 times 1 squared plus 4 times 1 plus 3. Well, 1 squared is 1, so times 2 is 2. So 2 plus 4 times 1 is 4, plus 3. 2 plus 4 is 6, plus 3 is 9. So I get the point 1, 9. Okay, so if I plot 1, 9, it's right here. Okay, and I can reflect it. It's 1, 2 away from the axis of symmetry, so 1, 2 away. I now have enough data to make my parabola. And that is how you graph in standard form. Your turn to try. Okay, find the y-intercept, the axis of symmetry, the vertex, and then go ahead and graph. Oops. Right. So make him just a little smaller. Why won't it let me make it smaller? There we go. Okay, I don't know what's going on with my graph. Right, whatever. We're not going to mess with it. We're just going to go ahead and graph. Okay, so the first thing we should probably do, I like to label what A, B, and C are. So A is in front of x squared, that's just a 1. B is 2. C is 4. Okay, so let's start the axis of symmetry. Okay, remember it's x equals negative b over 2a. So x equals negative b, so negative 2 over 2 times 1 is negative 2 over 2. So my axis of symmetry is x equals negative 1. Okay, so I'm going to go ahead and plot that. Okay, the next thing I need to do is the vertex. Well, I know it's negative 1 comma something, so let's plug in that negative 1. So I have negative 1 squared, 2 times negative 1 plus 4. Negative 1 squared is a positive 1. 2 times negative 1 is a minus 2 plus 4. 1 minus 2 is negative 1 plus 4 is a positive 3. Okay, so my vertex is the point negative 1, 3. Okay, so I plot him 1, 2, 3. Okay, I should find my y-intercept. Remember, that's just C. So my y-intercept is 4. So 1, 2, 3, 4. And I reflect him over. He's 1 spot away from my axis of symmetry, so 1 spot the other way. And 1 more point. So what's an easy thing to plug in? I think 1's easy to plug in. So if I plug in 1, so 1 squared plus 2 times 1 plus 4. 1 squared is 1, 2 times 1 is 2, plus 4. 1 plus 2 is 3, plus 4 is 7. So I get the point 1, 7. Okay, so 1, 1, 2, 3, 4, 5, 6, 7. Okay, notice he's 1, 2 away, 1, 2 away on the other side. And I have enough to graph my parabola. Okay, one more. Same process. I'm going to just go ahead and erase a little bit so we have some room to do the next one. Okay. So, again, I like to label what A, B, and C are. A is negative 0.75, B is 3, and C is negative 4. Okay, so let's start the axis of symmetry. X equals negative b over 2a. So x equals b is 3, so negative 3 over 2 times, let's see, negative 0.75. This gives me negative 3 over negative 1.5, which is just a positive 2. Okay, so my axis of symmetry is a positive 2. So I'm going to go ahead and dot him in. Okay, next thing I need to find is my vertex. Well, I know the x-coordinate, so let's plug in 2. So negative 0.75 times 2 squared plus 3 times 2 minus 4. Well, 2 squared is 4, so I have negative 0.75 times 4 plus 6 minus 4. Okay, negative 0.75 times 4 is a negative 3 plus 6 minus 4. Negative 3 plus 6 is a positive 3. Minus 4 is a negative 1. So my vertex is the point 2, negative 1. So 2, negative 1. Okay, next thing is my y-intercept. Remember my y-intercept is just c. So here's my y-intercept, negative 4. 1, 2, 3, 4. Okay, so go ahead and reflect. Notice it's 1, 2 away, so 1, 2 away on the other side. Okay, just need one more point. You can pick whatever you want. I'm just going to pick 1. Again, it's easy. Okay, so let's plug in 1. Okay, so negative 0.75 times 1 squared plus 3 times 1 minus 4. Well, negative 0.7, that's just 1, so negative 0.75 plus 3 minus 4. Negative 0.75 plus 3 minus 4 gives me negative 1.75. Okay, so I have the 0.1, negative 1.75. So 1, negative 1.75 is about right here. Okay, and just reflect and connect your dots. And there's our parabola. Again, notice A is negative, so my parabola opens down. Okay, so we're going to compare some properties. So we have fountain A is defined by this equation right here, and fountain B is defined by the table. So the trajectory of the water from fountain A is represented by a function in standard form, while the trajectory of the water from fountain B is represented by a table of values. Compare the vertex of each function, which trajectory reaches a greater height in feet. Right, so fountain A, vertex, we got to find the axis of symmetry. So x equals negative b over 2a. Negative b, b is 2, so it'd be negative 2 over 2 times a is negative 1. Negative 2 over negative 2, x equals 1. Okay, to find the vertex, I take that 1 and I plug it in for x. Okay, so this part you need to be careful. So it's negative 1 squared plus 2 times 1 plus 8. Okay, notice the x has the squared. The negative comes after that. So you square x, then you make it negative. Okay, there's a difference between this and between this. Okay, so whenever you see this, square it, then make it negative. Here you just square. Okay, so 1 squared is 1. I'm making it negative, so that's negative 1 plus 2 plus 8. We get a positive 1 plus 8 is 9. So our vertex is the point 1, 9. Okay, fountain B, I also got to find the vertex. Okay, remember the vertex is the turning point. So it's kind of like right in the middle of where the values repeat. Well, 5 is repeated, 8 is repeated. Oh, so this right here is my vertex. Okay, and remember, usually vertical distance is measured by the y value. So which function or which fountain has the higher vertex? Well, fountain B does. Okay, notice my y value is bigger than that. So fountain B has a greater trajectory. One more, we're going to have a function compared to the graph. Okay, so I'm going to go ahead and find the maximum. Another word for maximum is the vertex. Okay, so here's my vertex. That is the point 3, 0. Okay, so let's find our vertex here. So x equals negative b over 2a. Okay, here's a, here's b, here's c. So b is negative 0.6, so negative b would be a positive 0.6 over 2 times negative 0.3. Okay, so I get 0.6 over negative 0.6. That just gives me a negative 1. Okay, so so far I have negative 1 comma something. Okay, so let's plug in a negative 1. So negative 0.3 times negative 1 squared minus 0.6 times a negative 1 minus 0.2. Okay, negative 1 squared is a positive 1, so I have negative 0.3 plus, okay, negative times a negative, 0.6 minus 0.2. Negative 3 plus negative 0.3 plus 0.6 is a positive 0.3, minus 0.2 gives me a 0.1. So which one's bigger? Again, I only care about the y's. I have, stop that, I have 0.1 compared to 0. So f of x has the bigger maximum. Okay, no, so let's look at the differences between vertex form and standard form. Okay, so Mia is tossing a ball to her dog. Here's our function. Okay, what form is this function in? Well, that's in vertex form. Okay, so what does vertex form tell us about the situation? Well, vertex form tells us the vertex. It tells us the vertex is at the point HK, 2, 8. Okay, so the vertex is your highest point. So the highest the ball reaches is 8 feet. Okay, so the ball will go up 8 feet in the air. Okay, let's compare it to standard form. Well, this is in vertex form. Let's change it to standard form. So we gotta get rid of the parentheses. So let's do some order of operations. I have negative 0.5 x minus 2 squared plus 8. Well, I gotta get rid of those exponents first. Remember, x minus 2 squared is the same thing. So it's x minus 2 times x minus 2. So we have to FOIL. Okay, so negative 0.5 times x squared minus 2x minus 2x plus 4 plus 8. Keep going. Negative 0.5 times x squared minus 4x plus 4 plus 8. Okay, you need to distribute that negative 0.5. So negative 0.5 x squared plus 2x minus 2 plus 8. Finally, combine like terms. Negative 2 plus 8 is a positive 6. So what does this tell us? Well, just by looking at it, I know my y-intercept is 6. So that tells us the ball starts at a height of 6 feet. Okay, so vertex form tells us how high it gets. Standard form tells us where it starts. Okay, so one more example here. Suppose the path of the ball is different. We want to find the initial and the maximum heights. Well, the maximum is the same thing as the vertex. So the vertex here, HK, is 6.25. Max height is equal to that 6.25 feet. Okay, to find the initial height, we need to FOIL and distribute and combine like terms. Okay, so we'll start here by FOILing. So negative 0.25 times x minus 1 times x minus 1 plus 6.25. Okay, so if I FOIL, get x squared minus x plus 1. Okay, combine my like terms. X squared minus 2x plus 1. Okay, got to distribute that negative 0.25. Okay, 2 times negative 0.25, a quarter of 2 would be a half. So we got negative times a negative is a positive. Okay, minus 0.25 plus 6.25. Last step, combine like terms. Okay, so what's the initial height? Well, it's just my y-intercept. Okay, so the initial height is 6. Okay, so this ball is only going up a quarter of a foot. Okay, it's not going very high. And that is standard form. Okay, the big thing I want you to take away from here is knowing how to graph this. Okay, so I know your y-intercept is c, axis of symmetry is x equals negative b over 2a. I take that and plug it in, and that's how I get the rest of the vertex. Okay, that's the big things to know. So homework, you're on page 234, or 334, excuse me. You're going to do problems 11, 12, 21 through 35 odd. Hope you guys have a nice day.